Welcome back to the Explainer. So, you're staring at a microeconomics graph, right? And you're wondering, why on earth does the marginal revenue curve just fall off a cliff compared to the average revenue curve? Well, you are in the exact right place. Today, we're going to demystify this somewhat confusing relationship between marginal revenue and average revenue under imperfect competition. We're going to take all that abstract textbook math and turn it into something that makes complete intuitive sense.
Here's our roadmap for today. We've got 3 parts: the core rule, the textbook math, and the price cut penalty.
All right, Section 1, the core rule.
To make sense of the math we'll see later, we really need to understand the environment we're operating in. Think about imperfect competition, stuff like monopolies. In these setups, firms face a downward sloping demand curve. Basically, if you want to sell more, if you want to push more product out the door, you absolutely have to drop your asking price. You aren't just a price taker here. You've got to actively reel in buyers by making things cheaper.
It's a really brilliant contrast when you think about it. In perfect competition, your price tag, totally frozen. Doesn't matter if you sell 1 unit or 1,000. But imperfect competition, whole different ballgame. To convince that very next customer to buy, you are quite literally forced to offer a lower price than you did for the guy right before them.
And that brings us to this golden rule of microeconomics. As long as your average revenue, which is really just a fancy name for price, is falling, your marginal revenue must be less than AR for every single level of output. Except for the very first unit, your marginal revenue was always going to lag behind. Always. But why? Why does it sit below it? Well, to figure that out, we need to crunch some numbers.
Which brings us to Section 2, the textbook math. Let's prove the rule.
Okay, put yourself in the shoes of a business owner. Say you sell 3 units for 16 rupees each. Your total revenue is 48 rupees. Super simple, right? But wait, you want to sell a 4th unit. Because we're in imperfect competition, you can't just charge 16 again. You got to drop the price to 14 rupees to snag that 4th buyer. So now, your new total revenue is 4 units times 14, giving you 56 rupees. To find your marginal revenue, the actual extra cash from selling that specific 4th unit, we just subtract the old total from the new total. 56 minus 48.
But here's the kicker. The extra revenue generated by that 4th unit, it's only 8 rupees.
Wait, hold on a second. We've got a serious mathematical mystery on our hands here. How is it even possible that the price tag of that 4th unit, your average revenue, is 14 rupees, but the actual extra cash you get to put in your pocket, your marginal revenue, is a measly 8 rupees? Seriously, where did the other 6 rupees go?
When you plot this out, it creates a pretty dramatic split. Because of this exact math phenomenon, where your MR is 8 but your AR is 14, that marginal revenue curve just plummets. It drops aggressively below the average revenue curve. In fact, with linear demand, it falls exactly twice as fast. Pretty wild, right?
Let's solve this mystery. Section 3, the price cut penalty, and the case of the missing 6 rupees.
The secret here is what we call the hidden penalty of a single price monopoly. The equation is actually straightforward. Marginal revenue equals the price of the extra unit minus the revenue lost from the price reduction on all previous units. You see, you can't just charge your first 3 customers 16 rupees and your 4th customer 14. Everybody has to pay the new lower price.
Let's make this crystal clear with an out-of-the-box example. Picture this. You're selling custom gaming posters. You successfully sell 3 of them for 16 rupees each, making 48 rupees. Awesome. Then a 4th buyer walks up, but they're only willing to pay 14. You really want to make that sale, so you drop your price. But here is the massive catch. Because the market demands a single price, you effectively have to refund 2 rupees back to each of your first 3 buyers so everyone gets that same 14 rupee deal. You get 14 from the new buyer, sure, but you got to hand back 2 to buyer 1, 2 to buyer 2, and 2 to buyer 3.
So what does the cash register actually say at the end of the day? You collect the 14 rupees from the new buyer, that is your average revenue. But you instantly lose 6 rupees in past revenue because you discounted those first 3 posters by 2 rupees each, meaning your true net extra cash, your marginal revenue, is exactly 8 rupees.
Boom.
This proves exactly why 8 is less than 14 and exactly why MR is always less than AR.
This entire dynamic is the price cut penalty. It's the precise reason why setting prices under imperfect competition aggressively forces your marginal revenue down below your average revenue. Every single time you reach for a new customer by dropping your price, you are simultaneously cannibalizing the profit margin you would have made on all your existing customers. It's a trade-off, every time.
So I'm going to leave you with this final microeconomics thought to chew on before our next explainer. If producing more stuff constantly triggers this penalty that eats into your past profits and your marginal revenue is falling twice as fast as your price, when exactly is it time to stop the presses? At what point does the cost of making just one more unit outweigh that ever-shrinking extra revenue? Keep that in mind because figuring that out is the absolute key to understanding how monopolies maximize their profits. Keep questioning the math behind the graphs, and we'll see you next time.